Hi everyone, okay, welcome to Coding Bytes. I'm actually coming from the end of the video all the way back to the start because there's something I forgot to say. So this video is all inspired by the Beckhoff Christmas Challenge, where we've all been given terminals and we have to do something with it. So there is a amended license in this repo and this video itself, okay? So it's my Santa clause that you must follow. If you're a Beckhoff employee, there is the following that you must read. This one here, so competition Santa Claus. So during the Beckhoff coding competition involving the terminals, if any of the Beckhoff subsidiaries use, borrow from, or inspired by this code, they must acknowledge that via any of your LinkedIn posts need to include the hashtag Coding Bytes. That's all I ask. So again, I'm always one for sharing code. I enjoy it, and I think this is a really nice competition that we're all doing, and yeah, I'd like to see what everyone's doing. But obviously, yeah, we need to protect our entry. So definitely, if you take anything from here, if you carry on past this point in the video, or if you read past that line on the repo, it means that you're agreeing to it, and therefore any of your LinkedIn posts, Beckhoff subsidiaries, hashtag Coding Bytes. Okay, all right, on with the video. Hi everyone. Okay. Welcome to a very festive Coding Bytes. Now, I'm going to use this video as not my usual, so where normally you see me typing away and I just do something live. What this video is going to be is just me making my way through the repo that you've got available to you now to show you how I put together a bit of a project. I'm just going to talk to you about some of the classes I've made. But all of this whole video revolves around the Beckhoff Christmas Challenge. Now, all of us as the Beckhoff subsidiaries, myself in Australia, we have all received 4 matrix displays, a rope light and the EL2574 LED terminal. And we was told, we was instructed, come up with something, come up with a Christmas themed project and see how you get on. Now, what I did is, in order to do the whole unboxing and let's just see what we can make this terminal do, I started to put together this little mini project because I didn't want to commit too early of what we could make our final project be without actually seeing if I could get the terminal to do something that I actually wanted to do in the first place. So so this is the result of this. This isn't our entry by any means. We've got a new entry which is going to be coming, but obviously this is, you could almost say that this is my HelloWorld application. I thought it was quite a nice application, so obviously I wanted to share it with you all and again, just do the whole chat through. So EL2574 terminal, this is just an LED terminal that allows you to control those addressable RGB LEDs. It supports a huge number of protocols. It will support 2048 pixels off the card itself. Now we've got 4 channels on this card, but that doesn't mean you can do 2048 on each channel. It's 2048 divided up into how many channels you would like to use. So that means you could use one channel and talk to all 2048 pixels, or you could split them into 4, into 3, either way. Now, why would you go about doing that type of thing? From everything I've seen of the terminal so far, I think it's just for ease of use, depending on how you want to use the things you're connecting to it. So what does that mean? There's 2 modes this card is currently able to support. There's like a command mode, which means I can say, please set all the pixels to red. Please make the colors in a nice spectrum, like a rainbow, that type of thing. Please shift all of the lights down. That type of command, or set this block of pixels. Those type of commands I could see working really well for things like strip lights, the rope lights themselves. However, when you're using something like a matrix, I felt that was going to be really hard. If I was going to draw something and individually draw the pixels themselves, I felt actually that might be a rather large task, and I don't like doing things more than once, which is, again, why I'm a bit of a software engineer. So there's a second mode, which is the extended mode. Extended mode allows me to individually, it allows me to go through in blocks of 8 every pixel in my matrix and any other connected matrix, because as you come off the back of one, you go into the next, and it allows me to just set their colors just independently. And so it's a case of sending 8 pixels, 8 pixels, 8 pixels, 8 pixels really fast. And what it allows me to do is build up a picture, and as long as I've got something which can take a picture apart and to serialize it into those correct 8 pixels, it's just a game then of I can just load in a load of images, throw them into the terminal, and away we go. So that's the route I decided to take. I like the command mode because if you want to make things flash or walk or make things move around, very nice. But I wanted to see if I could get some images on here, and especially images, animation. Could I put live video feeds through it, for example, which is, from everything I've seen so far, completely possible. Very pixelated, but absolutely possible. So these, you'll see it in the documentation. So we've got, I won't go into this too heavily. All right, this is the Coding Bytes video, but I also want to keep it sort of fairly short as far as Coding Bytes videos go, just to give you the flavor of it. And obviously you'll be able to pick the code apart yourself because the code's already there. I'm just going to help you through it so you can understand the code more. So we've got command mode, which is the first one. They give you a bunch of commands, a bunch of variables that you fill in, and by following a timing process of put the command in, toggle execute bit, we can then update and send, those type of things. You'll see whatever you've asked it to do go out onto the terminals, onto the terminal and onto the subsequently connected LEDs. So that's what's classed as command mode. And again, from everything I've seen so far, you can pick if you're going to do command mode or extended mode per channel. So which is why I think we've got the 4 channels, because you might do a rope light on some, you might do matrices on the other, and a mode definitely suits one rather than the other. So that's why I kind of see it. So that's command mode. I skipped over that. I like it, but I did think, no, for what I wanted to do, I wanted to show things. So I quickly headed off into what's classed as extended mode. So extended mode, you have to select the right part of the PDO. So to bring the PDO up, if I just open, oops, my IO, we can see I've put the terminal in here. I've got a few inputs and outputs because that's what we're going to be using on our final. And okay, so just opening this up, I've got the extended control instead. So this one just in here. Now, how that was done is I just went in process data and just unticked the first PDO assignment and just ticked the second, and it just gave me the second itself. Now, if you want to use more slots, there is a slot configuration up here. And again, you just move them across and say what slots you're going to be using. But I'm just using the single channel for the time being, just because. I was able to achieve everything I wanted with a single channel using extended mode. So I like it. And what we can see here, instead of firing off commands to the card itself, what we actually have is an index, this index here. This is telling the PDO, or the card, what group of 8 LEDs am I going to speak to. So index 0 being the first 8 LEDs, and then I make our way up until we run out of LEDs, put it that way. So I can update the content of each LED, 8 LEDs in one go. Now it's a case of setting the index, set the value, say that, put right as true, and I toggle execute. So execute itself, I only have to toggle it between states. So if I was false, I go true. If I was true, I go false. That it's the change of state that causes it to occur. And if we just see here, they actually speak about what procedure you should be taking. Okay, so so again, we're just going to be setting that right bit and toggling the execute bit. And we just do that over and over again. So all I'm doing in effect is I've written a class that will serialize an image. And so when I say serialize an image, I've told it, hey, you're responsible for this bit of the image. You know where you are in that image. And when I ask for your pixels in serialized order, you give me back the pixels in the order that the matrix wants, because every matrix could be different. The matrix we have actually does like a zigzag pattern through the LEDs. Had that have been rows 1 by 1 by 1 by 1, I'd need a different serializer for that, because in other words, I need the pixels in a different order. It's not the job of the card to know that. It's the job of the thing serializing my image, ultimately. So yeah, so this is the technique I'm taking. And you'll see in my code as well later that I'm doing this whole iterate over all the pixels I've got. And then once that's done, I then do send and update at the same time. So send and update, toggle execute. And what actually happens there is there's a little buffer that's... where are they? Just move up. So we've got a pixel buffer and a frame buffer. You can actually see I'm triggering update and send straight away. You're allowed to do that. You're allowed to do update and send at the same time. You're actually allowed to do write, update and send all at the same time, and it'll take immediate effect. But what I'm doing is I'm using the write command to prepare the pixel buffer. So it's got the image that I would like it to have. And at the end of me updating all the pixels, I then trigger update and send by turning both of those true and toggling that execute bit. And it puts all of that out onto the pixels. I can then start my job of filling out the next ones. So that's how the card's actually working. So let's have a look at a little bit of the code itself. So let me just take apart the code and show you what I've written. So hopefully more comments than I ever put in a program normally, because, well, why not, eh? Why not? Hopefully it allows you to see it. So when we go live on this demo triggers, you're just going to, this will automatically default to true, and there is also a clear as well. You can actually turn it to false and just do clear as true, and it'll clear all the LEDs down themselves. So helpers. Now, what way shall we go about this to start with? I think I'll show you, because again, I built this up with a concept first. So in my head, I felt that there's this notion of a serializer, because I obviously, as far as the card's concerned, I just need to serialize from the first LED to the last LED. I need to put out the pixels in the right order. Now, that has to go out as a serialized, just one pixel after the next, after the next, after the next. So I felt there would be an object which I tell it which part of an image it should look at, and it should know how to serialize the pixels of that object. So that's actually where I started. So I wrote an image serializer. Now you can see in here, I decided to use inheritance because I feel that there'll be different shapes of serializers, because if I've got a ring light, if I've got, obviously matrices are pretty much covered because you'll see I've set them so they can have any size. Strip lights potentially, but that's just a matrix with one by however many, but still it might be nice to have its own serializer. I might have triangle shapes, those type of things. So anytime I introduce some form of serializer, as in it represents the kit that I'm connecting ultimately, because it's the thing that has to take those LEDs and display them. So I made it into a base. So the image serializer base to start with, they all play pass the parcel with each other, because the way I saw it too is because they're physically connected to each other. I felt that once I connect all my serializers together and tell them all what image they're looking at, my main card only has to ask the first one in line, hey, can you give me your first pixel, second pixel, third pixel, fourth pixel? And it just replies them out one after the other. They know that they're connected to other bits of kit. And so if I connect all these objects together in the right order, if I now ask this first one, hey, can I have your 10,000th pixel? It might not have 10,000 pixels in it, but because it knows it's connected to the next one, the next one, the next one, the next one, they all go, hey, that's not actually for me. I'll deduct how many pixels I have, off that as in how many I have, and I'll ask the next one in line, can you give me the pixel for what was asked for minus how many I know I've got? So by the time you get through all of the different stages, finally, the serializer who matches how many pixels are actually it's being requested will be the one that goes, that's mine. It'll play pass the parcel and send it all back. So that long chat there meant that my image serializers needed to know who they're connected to next. So I've got a method on here which is connect to. So I'm allowed to pass in a image serializer, because then I have to use interfaces with this, because an interface allows me to pass in any image serializer as long as it obeys connect to, get total serializable pixels, how many pixel counts you got, try and get my pixel, that's the big one, and update image. So image serializers, as long as you implement all of those methods and properties, you're allowed to be connected to the next one along. So we can have any shapes, any sizes, all those good things. So connect to, all that does is set inside there's a variable, just called next, and that holds the next serializer. If I try to do things like, that's the other one. So whenever I talk to the thing next to me, you've got an option. You've got options when you do this type of thing. You could say, do I have someone next to me? And if so, I will do the operation I wanted to do with them. Or you can implement the null object pattern. So null object pattern is just where I make a null image serializer, and anything I ask of it, it kind of either rejects and says, no, I can't do that. Or if I say, can you give me a pixel? It goes, no, I haven't got a pixel. Or if I say, hey, how many pixels do you have? It'll come back and say, I've got 0, that type of thing. Now, the beauty with a null object pattern is it means the class who's talking to it, it doesn't need to do any pre-checks to say, are you even there? Because in other words, I've said, hey, don't worry, you're a class. Someone will be at the end of you. I've put a null version of it on there, which means this class needs to do no checks to say, is it safe to even talk to the person next to me? Because if that was just like a pointer or an interface that hasn't been set, that would be a memory exception, because you go, hey, how many pixels do you have? And it'll go, no object here, no one to talk to, memory exception. So I've implemented the null object pattern in this one. So if we just have a look back in the image serializer, I make a null image serializer, and the first person I say, hey, next is someone who is image serializer, and I pass in a null image serializer. So the minute you start up as yourself, you get someone next to you, but it's just null. So now you're allowed to do things like get total serializable pixels. So all I'm doing is returning my pixel count, for example, and I say, hey, next serializer, can you do the same? And that's what allows this play the pass puzzle. But by the time, if that just happens to be the null one, it's just going to reply back 0. So that means the total pixel count is actually my pixel count plus 0, that type of thing. If I say try and get pixel, this is the thing that I was speaking about just earlier, where I say, hey, if the pixel is greater than how many pixels I am, then technically it wasn't for me, but I can deduct me off of it and send it to the next person. So new pixel index is pixel index, take away the count. And then I ask the next serializer, can you try and get the pixel instead? And we just play that pass parcel. I'll speak about this pixel reader just in a moment, but otherwise that's it. If it clears this, if it says, no, this pixel range, this is, if you've asked for pixel 5 and I've got 10 pixels, it's in my range, I'm allowed to process it. So what I do is I'm actually calling a protected method up here on try get pixel, which means I'm actually asking the child class, so whoever's inherited from me, to handle this, because again, I'm the base class. I don't actually know what shape I am or what I do. So in here you can see on try get pixel, it's just a blank method and it's abstract. So it means anyone who is or extends from image serializer will be forced to implement that method on try get pixel. They will be told what pixel index they want to, as in you've got to give me, and I also pass in a reader, which again we'll speak about in a moment. So by the time we get to this part of the method, we know that it's safe, it's in our pixel range, we should be able to just say, yep, absolutely, we can do all of this. On update image, so how all of this is working, so this one here, so if someone passes me in an image, I'm using ITCVN image. This is TwinCat Vision. So my entire project is actually based on TwinCat Vision itself. So there's like the little hidden, this is how I'm reading images so fast. Don't get me wrong, you could write all of this tools based on your own bitmap manipulation. So you could load bitmaps, you could, all those good things. I've decided to just jump forwards and go, well, TwinCat Vision knows how to manipulate and use images. I'm just going to ride off the back of that. Okay, so that's one thing. If you're using this code just straight out of the box, you'll do a trial license for TwinCat Vision, and it allows you to just work with images. So again, I'm just doing a quick check there, update the image. That means someone's just said, hey, can you just update the image that you are going to be looking at and serializing. I do a quick check first. If the source, if that is empty, then just get out. I call on update image, so I call again a protected abstract. I say, hey, child class, you're responsible for actually doing all of that because you know what shape you are, you know how to handle it all. And then the next thing I do is we play pass the parcel. Next serializer, can you update your image? If it was the null one, it would just say, thanks, I'm done, we're all good. So we play pass the parcel as well with that. Pixel count, this one here is abstract because again, the base class has no idea how many pixels this thing has, if you're square, if you're circular, that type of thing. But I make it abstract because I knew I needed to use the value of pixel count in this calculation. So that's why you use abstracts. You say, hey, I know I'm going to need to know these values, but but I can't implement it as the base class. It's just one of those things. So the minute I implement or I extend from this, this is one of the things I have to do. Next serializer as well, I've just made a property which just exposes the next serializer. And connect to, obviously that's the thing that says, if I pass in someone who is an image serializer, make my own internal variable, if the image serializer is equal to 0, next equals, yeah, so in other words, I do a quick check. Did someone pass in nothing to me? If so, I'll make my next back equal that null version again. So in other words, I put my null serializer back. If someone did pass something in, if it already is equal to the one I already know about, I just return straight out, and otherwise I make my own internal variable what they passed in. Really, that step's kind of redundant, but it's just one of those things. That I expose via this next serializer, because really, when you're working with parent and child inheritance, you don't want people to know about these variables. So it's one of those things, because we do a very good job of doing dependency inversion, all those good things, which protects us knowing too much about the outside world, about everything else. You tend to find that if you're doing inheritance, you end up finding that you become really highly coupled with your parent. And one of the ways you can prevent that type of coupling is, if I know, well, I'm forcing people, if I say, well, yep, you need to know who the next serializer is, I make it a property. So it means that that's accessible by people on the outside, but also people who are extending from me. So they didn't need to know what this next variable was, because I never want people just taking a guess and saying, it's all right, I kind of assume I have a next variable inside me because I inherited someone, because I might change the base class in the future and all of those children classes will break. If they're all using my public property to get the next, well, that's a lot more stable, because I can now do whatever I like inside here. That's what I mean. So try and expose stuff that way. If you turn around and said, whoa, I don't really want to expose the next serializer, say for example, just out of, I do want to force the child class to implement something, for example, on update image, on try get pixel. Pass the things that you think they will need through the method call. So if, for example, you're saying, hey, can you do this for me, child? And it needs to know what the next serializer is. Pass it up through an argument in this method call. Okay, so I don't want to go too deep, but again, this is Coding Bytes. I tend to go a little bit off topic. But try to make your parent class as standalone as possible. And if you're forcing the child class to use things that the parent class has, use either publicly accessible stuff anyway, or pass it up through the method call. Don't make people find your internal variables as the parent. That's a big no-no. So for example, when I made my matrix image serializer, which extended off of image serializer, there is definitely somewhere, I think, where I get my pixel count, quite possibly on update image. No, maybe I didn't end up using it in the end. But had I have, it wouldn't be pixel count because that's something I have to do. But if, for example, next, no, I don't force anyone to even need to know next anymore. But had I have done it, they could have used a publicly accessible property on the parent. I don't want anyone in here ever touching any of these variables directly, because I may change their name, and if so, this child class may break. This child class may actually be in a different library, for example, and suddenly you've got broken libraries and people go, why is it broken? You go, I changed the internal name of the parent. People will be like, whoa, that was highly coupled. So again, danger signs. If you ever touch variables in your parent, danger, here be dragons, put it that way. So you've done a good job of doing OOP, because obviously that's going to help you with decoupling, but you've just massively coupled your child to your parent, and that's what you don't want. So yeah, all right, I think I've just banged that drum way too much. Okay, so that was the image serializer itself. It as a base class has only the notion of connecting to a serializer, having this notion of updating an image and saying, I'll just check it first. Yep, no worries, I'll let the child do it. And it also has this notion of, hey, you want a pixel? Is it one of my pixels? No, I'll pass it on to the next serializer, or yes, it's me. I'll let the child handle that as well. So we've used this parent class as a way of just doing all of those general things. Because now if I have a circle image serializer, I know that all I have to really do is implement the pixel count, work out how many pixels I've got, and try get pixel and update image. They're the only things I really need to handle. Everything else I handle is based on me being what I am, a circle, a square, that type of thing. So there we go. I'm also bringing in the interfaces because obviously I don't know who's going to connect to who, so you just have to be an interface. Right, so long story short, this is therefore my matrix serializer. So starting off, when I construct it, I have to give it a height, a width of the panel, and I give it an X and a Y position of where it sits in the master scene. So you could think of it as that's being its physical X and Y position, because the image I'm going to give to it, it's going to try and pick out, if this was a 16 by 16 00, it will try and pick out the 16 variables at the very 00 point of the image. And I can move that part around. That's the whole notion of saying I have a matrix. And not only do I tell you its size, I tell you it is where it is on the master image. Tiny, nice. So we just store those. We tell it to initialize. Initialize, I just calculate how many pixels do I actually have, because it's all based on width and height. And pixel height just pulls that out. So it just saves it doing that calculation every time someone asks you how many pixels it's got. So the first one we do, on update image. So I'm using functions from TwinCAT Vision in this. So the first ones I'm doing, so I'm being passed in a source image. That's all. The first thing I do is I copy the source image. So I make my own copy of it and I put it into a variable called image. So that image there, that's my image. I also have a live image too that you can actually see. But anyway, on the side. So the first thing I do is I say, oh, thank you very much. This is the image you want me to be. I'm copying it. I've got my own version of it now. So the first thing I've done, copied that image. The second control I use is set ROI. What that does is it takes my image and it will pick out a position based on its X, Y, width, height, and it will technically zoom in on it, and that will become my image. So I'm setting the region of interest, ROI's region of interest, on the image based on my X, my Y, my width, and my height, and that's it. So what actually happens there is this suddenly contains an image which is the right size for the matrix in the right position I told it where the matrix was sitting. So 2 lines of code there, and I've just said, hey, have an image, and it goes, nice, I'm this bit of that image, because that's where you told me I live. That also means as well, in the future, we could actually make things that move a matrix's position. Let's say we put it on an explainer tile. We can move it around, we could change its location, and this thing would know what it's doing. It would know to move around and pick different parts of the image. We could actually support rotation as well. That's all possible, but I didn't in this instance because I wanted to keep it small. All of these TwinCAT Vision functions return a result, and we feed the result into the next one. So if this were to fail, this one actually doesn't run because it takes the result of the previous, and we'd start it off with SOK, which is actually the default of, yeah, away you go. If we succeeded, because that's a H result, so if that is a succeeded H result, then I actually do a copy into displayable image, which is allows me to see this live. So you don't need this line. This line is just, I'm just putting it into a variable so I can actually see what's inside of everything. I'm actually connected at the moment, I believe. So if I just do ADS image watch, and I'll just bring it over. So let's just bring this across over here. Reload images. So you can see my 2 matrices. So you can see one and you can see the other. So that's the only reason I'm doing copy into displayable image, because I just thought it'd be nice to be able to see what's actually going on. Okay, so if it succeeded, it does that and it returns out. So I return out early, done, which means if I get past this line here, something went wrong. So if the image, I tidy up. So if my personal image is equal to 0, it means I never got an image in the first place. I can now return out. But if that is something other than 0, it means that I have an image in me. Let's release it and then set it to 0. So it's just a little bit of tidying I do because something went wrong. I'm clearing the image away. I don't want it anymore, that type of thing. If all of this is always successful, this always overwrites the image, which means we just have this rolling image that just gets updated every time. And it automatically releases for us all those good things. So that type of thing as well. Nice. So that's the only code you need to make a matrix understand where it lives in the world and gives it its image. Done. So how that ties into the main code? It's that line there, matrix 1, update image. That's where I'm passing in the image. Now we can talk about this animation current frame at the moment. Just to think of that as the image I want it to show just at that very moment in time. So update image. It plays past the parcel and says, hey, these pixels, this is for me. Takes a copy, sets its ROI, then asks the person next to him to do the same thing too. So that's why it ricochets through it all. You can also see here on initialize, this is my initialization code. I connect matrix 1 to matrix 2. And you just play this game. If you've got more matrices in whatever order, you just connect. They all become their next. The last person in the line has the null, which means it says, hey, can you update your image? And it goes, don't do anything with images, but thanks very much. That type of thing. Okay. So this now means we could do a crazy layout with matrices. We can tell them all which part of the screen that you should be referring to. All that mechanism is in place now. We're halfway home. We're almost done. Next, try and get pixel. So try and get pixel is we're asking the matrix its pixel. So we're saying, hey, based on a pixel number, what pixel does that represent physically on you? So we know by the time we get to on try get pixel, we've already assured ourselves it's our pixel, it's in our range, and it should be just a number between 0 and our maximum number of pixels. Okay. So if I do a quick check, if us is nothing, if we're not an image itself, we should never have got that far anyway, but I just drop straight out and say, no, you can't have a pixel on something that I don't even exist. I then say, so these lines of code here, so pixel index modulo with width and pixel index modulo divided by width. What this thing does here is when I have rows and columns, it allows me to say based on 0, 0 being the very top, that would be 0, x position 0 and y position 0. So I'm making my way along to say, let's have a look. So y, yeah, x and y position. So the higher the number I get, the more I would make my way down and along. So because it wraps over and over and over again. This is what if I do a mod and a divide, all I'm doing is I'm turning a number from, if it was a 16 by 16 pixels, I'm going from 0 to 255. It tells me where in a grid I am based on the width. So it's like a wrapper. It just goes, oh yeah, otherwise it'd be really long, wouldn't it? All it does is it wraps it down. It tells me what row and column I'm on. That's all that those lines are doing there. So it's telling me where I am in my image should I find my pixel. Now the crazy part is these matrices, every odd line run backwards. So it actually runs the pixels along, back, along, back, along, back. So it means that when I find my my x position, so when I'm looking for my x position, for every odd row? Yeah, for every odd row I go, it actually is facing the other direction. So what I'm doing there is if I'm on that row, I just take my width and 1 minus width minus the position. So what it does is it actually spins it around the other way. So in effect, as I count my number up, I make my way along the pixels, drop down, make my way back, drop down, make my way up. So this code here is the code you use to determine based on a number of pixel, where does that physically represent in your device? And that's what makes you a matrix image serializer. If I was a circle, I would have to do some circle maths to go, well, the pixel's about up here. If I class every pixel's being square and I have to hit the circle, maybe I ignore a load of pixels, that sort of thing. If it's triangle, what shape would that be? That type of thing. So this is the code that defines who I am to be a matrix image serializer. Once I've worked out the position based on the pixels index, I just say fen get pixels, pass in the image that I'm currently holding, which we remember is already set to the region of interest. This one's a bit of a funny one, but based on the XY position, and don't worry, we're all good, there was nothing before me, and the successfulness of that is on this on try get pixel. So because again, I write often try do something. It's a nice way of saying, hey, I'm going to give you everything you need to do your job. I even give you a place to write your result. Can you just tell me if you did it or not? So I tend to sort of gravitate to the try pattern. If things are failable, I tend to use try, because it means you can do if try get pixel, or if not try get pixel, that type of thing. You can embed them in if statements. It's great. So time to talk about the pixel reader now. So what I'm saying here is this function, it wants me to have a variable that it can write the value of the pixel into it. Now, because this is TwinCat Vision, our pixels are this value here. Sorry, I can't remember it off the top of my head. Pixel reader value is a TCVM vector 4 LREL. So that's a very smart way of saying it's an array of 4 long reals. It really is. If I go to definition, you can see it's just an array of 4 LRELs. Done. That's because TwinCat Vision, it'll work with more channels than 4, but typically people are using 4 channels. So because it tends to be RGB and alpha, or it might be well, any of the other different styles. I mean, obviously chrome, monochrome is only going to be a single, but they've standardized to say, look, quite often when we're working with this, we'll give you 4 long reels, because again, we don't just support 8-bit images. We can support images which are using decimal places. It's one of those things. When you get into Vision, and suddenly you realize actually there's more to life than just 256 pixels, 24-bit pixels, that type of thing. You suddenly realize actually, yeah, using 0 to 3 of long reel, you're good. You can cover almost everything with that. So in here, the card itself uses unsigned double integers. Unsigned double int? I think it is. Let me just double. Yeah, unsigned double integers. So in other words, I'm saying, hey, I want you to read. I want you to give me the value of the pixel. But the card, the EL terminal, doesn't want a vector 4 LREL. It wants an unsigned double int. So I could have just written into it, I always give you back an unsigned double int. But that fixes our code to only working in one way. What if the next image serializer and bits of kit needs something else? Let's say, for example, I have another terminal and it says, no, let's not use an unsigned double int, we'll use an unsigned lint, for example. Well, I have to rewrite all the code. So what I thought would be a good idea is if I could say, hey, when you read the pixel, I'll give you someone that you write your long reel, your vector 4 LREL to, and when you tell me you've done it, I will ask the thing that you spoke to convert it for me to what I want it. So in other words, I can give you my pixel reader, which will always support being fed vector 4 LRELs. But behind the scenes, I've given you a reader that knows how to give me back the thing that I want. So I'm playing this game. So this reader here, all it is, simple thing, it implements pixel reader. And to be a pixel reader, you only have to take a value from a TwinCat Vision image. That's it. So you just have a value of vector 4 LREL. But my pixel reader itself also has read as udint. So when I say, hey, can you give me that value back as a udint, it breaks the vector value back up, puts it in my array of bytes, and then it does a quick mem copy and sends the result out as a udint instead. So this thing here, if ever I had to support different pixel types for different bits of kit, I just change my reader and we're good. So again, maybe a little bit excessive for this example, but yeah, I tend to program decoupled anyway. I don't like fixing myself to saying, oh, now this code only works for udints. Why not pass in a reader and let it be able to work out the conversion? And I can swap that out later if I need to. So there we go. So that's why when we say try get pixel, we're actually passed in a pixel reader. This function just writes to that value of it, and then later I read the pixel out. So we're good. So that's it. So that's the image serializer done. So we've covered the image serializer. We've covered the pixel reader. We've covered the null serializer. And the next thing we'll just cover is try send pixels. So this extended mode. So this thing here is my terminal in essence. It's got a little state machine in there because it has to run through a certain number of steps when it's sending stuff. It's got a PDO, which is actually what's linking to the card itself. Now, in order to do that, all I did was just double click on this, say PLC, tick per channel 1, and it makes a data type for me. Hit copy, and as long as I shove that in the object itself, when I say link to PLC, it just shows up in here. So, which is really handy. It's an easy way of linking every variable from a PDO. But the only downside with it is it comes with the naming that they decided to put in there, which can sometimes be a bit long, but still, it beats typing it. So that's the PDO, that's the thing that gets linked. I also tell it how many pixels it itself has when it first starts, because that's needed in my calculations. I have so maximum pixels. So I know this terminal itself can only support 2048, so it means I'm going to actually have my own buffer of pixels. So in other words, I'm going to say, you may be able to serialize an image, but you give me someone serializable, I'll serialize from it and I'll put it in my own buffer, because at that point there, I'm going to lock myself down and go, right, thanks for that. I'm going to now start sending these, and these are mine. You're not allowed to touch them anymore. And someone else might go, hey, can you send these serialized? And it goes, no, I've got mine. And it allows that to break away and start doing its new job of doing other pixel stuff things. And I have my own copy. So this send buffer is mine. I have to keep track of what send segment I'm on, because remember, we go up in 8s. So that's just something in here, and the current segment itself. So how many segments do I need to send, and what is the current segment I am sending, and the rest is just for the state machine itself. So we'll just have a quick look in here. So we'll do this one first. So try send pixels from serializer. So someone's going to give me a serializer. Now that can be the matrix, because the matrix itself is a serializer, because it implements image serializer, which by the base is image serializer. So I can say, hey, can you send, here's a matrix, can you send that? And because the matrix is connected to other things, it will send them as well. That's the way I've just decided to use it. If I'm currently busy, then I return out, and because it's a try, you don't get the true at that point. So in other words, people can try and it goes, no, you're not allowed to. Otherwise, it does a check and it says, hey, image serializer, can you get the total serializable pixel count? So again, that's that method I can call, and it daisy chains through all my serializers. It tells me how many pixels are there. So how many pixels do I have? Lovely. Is it greater than the total I'm allowed to send? If it is, I return out. So you get a false. You're not allowed to send things with more. So if you wanted to support obviously errors, this is where you do errors, this type of thing. I then, once I've passed those, I say my state is initializing. I reset my send buffer because I'm done. Clearly I'm done with the rest of it. I create my send buffer from my serializer and I just pass that in, and then I send back true. So I've done two private methods in here. So at the moment, I just mem copy nothing over my entire send buffer. And then this one here, while the image serializer, try get pixels from my current pixel, which is starting from 0. Here's my pixel reader, which is that pixel reader. Because it's a while, I'm saying, hey, while, can you get 0? And it comes back and goes, yep, done that, because it returned true. I can then say, make my send buffers the current pixel, so in other words, my copy, pixel 0, can you please read the value that come out of the reader? Because the reader got set during that call, and now I say, hey, can you give me the value in the one that I want? So the people who use the pixel reader, they don't know what type of reader it is, because only I get to see that because I own the reader. They just see it as someone who they can write set value to. Okay. So while it's true, I take a copy of the pixel, I add 1 to the pixel, and we go again. Can you get pixel 1? Can you get pixel 2? Can you get pixel 3? So by the time we actually run out of pixels, because in the end, we're going to hit the null serializer because we've fallen off the back of all of them. The null serializer goes, no, you can't have that pixel because I haven't got it. And we fail. We return false, which breaks the while loop, which means we've stopped serializing. So that code alone has now filled up my send buffer with the perfect representation of my image serialized in the manner that my serializers wanted it. Now that's crazy. I mean, that's a really handy thing, because all of a sudden I've got to a stage where I can have any shape serializer I like, because it's the serializer's job to say, you show me a bit of picture that I'd like, I'll tell you how those pixels are serialized out from pixel 0 to pixel whatever. That's it, done. So the world's our oyster now, and we can do whatever we like. The next bit that we do is just during a cyclic call, we've just got a simple state machine. So I start off on initializing, just set all my variables to nothing. And then we go straight into send segment. We tell the index it's the current segment. We set all of the pixel values to the send buffer based on the current segment, so 0 to start with. 0 times 8 is 0, plus 0 is nothing, so that's the first pixel. The first, second, all the way to 7th. We toggle, see that's where we do the not of the execute, and obviously we've got right as true. We toggle the execute, that takes place. Because it's EtherCAT, it's synchronous with the PLC program, which means I don't even have to wait for a busy to complete, because that took that. That's fine, that took it, nice. If the current segment is the same as the send segment, because I do keep track of how many I need to send, then I trigger the frame send. In other words, time to put it to the LEDs. But if not, I add one to my segment and we go again. The nice thing is the state machine will naturally drop out. It allows EtherCAT to update itself. Those values got written. Around and round and round we go. So we're going up in batches of 8. Even though its current segment index is 0 to however many segments, the segments are of 8. This is what gives us that 8 times multiplier plus our offset of the send buffer. So we're making our way through the send buffer. By the time we've sent all of them, we do this final thing. I set right to false and I do this double bubble. I do update and send at the same time. I could use a 2-stage if I wanted to, but to be honest, I think it's fine at the moment. Update and send at the same time, and I toggle execute, and then I send for wait for frame send complete. And frame send complete, I am actually watching for busy on this one, because it's going to do its job and take a certain amount of time to do. I will wait until it's not busy, and then I reset those 2 values and sit in idle. And idle sits there until someone else then can do this, because if busy is based on not idle or errored, yeah, that's it. Send clear is exactly the same thing, apart from all I do is reset the buffer and set it to initializing. So I just send out nothing at the end of the day. That's it. So that's the EL extended mode. So that's done as well. So we've done the image serializers. We can understand how they work now. The thing that's just going to knock them out the port as fast as possible every time I do it. So if we look at main again, you can now see update the image and then try to send pixels from the matrix itself. All good, nice. I'm not actually looking to say did that do it or not, because I'm doing everything so slow. This whole thing's running at 100 milliseconds, 100 microseconds. It's keeping up, it's fine. Had I need to say, whoa, I might be beating the update rate of the card with my PLC cycle, I'd actually include this in the if statements to say, well, as long as the it's been triggered, as in you're allowed to go now, and you're not busy, like as in I only move on to the next frame if I'm sure that that one was sent. Okay, so but I mean I don't actually check. So that's what's pushing these out. So anything I give it as an image, all the serializers do their job, and then the EL terminal serializes out what sends out what was serialized. Good. Last part of all, and actually that's the cyclic call you can see there. Last piece of the puzzle is the animation object. So just this one here, which I've called it the Sprite sheet animation frames. Now it has a constructor, so we tell it where do we find the image, how big, what's the width and height of the sprites, how many have you got, and are they in what columns and rows are they in? So that's all we need to know. I use this technique of try load. So it just takes that and goes, yeah, that's lovely. You haven't asked me to do anything yet. It's not. I'm not even going to bother loading it. I use try load because what's nice about try load is you can. I mean, obviously you'd have to do it slightly different if you have the rest of the program living underneath. But if the animation try load, if that's coming back as false, I return straight out. So I initialize, come down here, try and load it, and it sits there going busy loading because it's asynchronous. Busy loading, busy loading. I just keep returning out, because there's no point doing the rest of this stuff if I haven't loaded my animations yet. The moment that goes true and goes, yes, I have loaded, the execution's allowed to continue, the rest of the code runs, and every time I say try load after that, it just goes, oh, you've already loaded. No worries. True, true, true. So that's fine. So this is what I do here. So if I hold a sprite sheet image, which is an ITCVN image, just an empty space. If it's anything other than 0, which means I have an image in it, then I'm done. My job here is done. I then, if I've got past this, because again, I tend to use this defensive style of programming where I go, I check stuff, get out, because it allows me to then just, there's no nesting of my if statements, because I just go, how about this, get out, how about this, get out, that type of thing. It's really nice. Then I do a check. Have I got something in my path? Is the width, height, total sprites, columns, or rows 0? Because that means that it's an invalid setup. We get out, we're done. So from this point here, we know the path is good. We've got valid data at the end of the day. I trigger read image. So this read image here, I put true because it's just once only. If this thing fails, it's just going to get stuck. I don't mind that. It'll just sit there with error and it will never run ever again. So because I'm not expecting to have a user like interface, people to be able to restart stuff. So read image, that is just up here, FBVN read image. It will try to put the, there's a file path, the destination image, read as true, timeout after 500 milliseconds. So if I come down and say, are you busy? I get out, because I can keep looping over and over and over. And because you have to keep calling this function block, that will finally change from busy, not busy. If there was an error, I just return over and over and over and over. That's where we get stuck. But as long as there's no error, then we should have an image. So I double check, because that should have put the image in my variable. So if my variable is still 0, something really bad went wrong. I don't know what went wrong, but I'm just returning out as well. Otherwise, I tell it to move to start and send back true. Done. And from that point on, the next time it comes in, this will be non-zero, so we'll return true over and over. Move 0 says I set my frame index to 0 because I keep track of what frame. It's animations at the end of the day, so I've just got a number of frames. And I try to get the sprite based on the index and where I want to put it. So current frame image. So I've got a second image. So I've got the image, which is the sheet, but I have the image, which is the current frame's image. So that's a private. And I say, if you've asked for an index that's greater than what I've actually got, drop out, you're not allowed it. I then play that game of finding my rows and columns again, because again, all I'm doing is serializing. I say, oh, I want the 5th, and it goes, well, how many rows and columns have you got? I'll put you in the right place. So that's the first thing. I then work out how big, so based on how many there are, I have to offset that by the width and height of a sprite at the end of the day. So that's the second thing there. So I work out the X and Y based on what row and column I'm on, times the sprite's height and width. I copy the image out, set the ROI, same as that last one, and send a result back to say, are we good? So by the time I say move to start or try load, the end of try load, in my current frame image, I have the image of the right part of that deck. And now if I say try move next, as long as I'm not at the end, otherwise I return out and you get false, I add 1 to the current frame index. I try and get that sprite, and the result of that try is then passed back to the user. So now you can see that's the final piece of the puzzle. That's it, we're good. So I've set up my matrices, I try to load them, and I just keep rolling until finally it's loaded, which takes milliseconds, by the way. If the clear is set, I just then try to send clear all, which resets the buffer and passes it out via the state machine. Otherwise, the animation logic, I've put in a rising edge trigger here. So rising edge trigger, if my rising edge trigger of my start animation is goes true, as in it rises, I just simply say animation move to start. So we now know that's copied and ROI'd the right part of the sprite deck. And then forevermore, if start animation is true and I have 100 millisecond just pulse going at the moment, just what it's doing, I tell my matrix to update to the animation's current frame image, which will be 0 at the first time, which immediately ricochets through all my serializers and they're all prepped and ready with it. I then say, hey, EL terminal, can you send pixels from a serializer? And I give it the first matrix. It goes off and collects, as long as it's not busy doing something else, it goes off and collects all of the pixels and says, yep, that was good. And then if, because it's a try move next, I return false if I can't go to the next frame, because there are no more frames. Animation try move next. If it fails, then that's a not. So it means animation move next, and away we go round and round and round. And that whole code there allows me to pass in images, and you see that occurring. And that's pretty much it. Someone's turned the lights on, so actually you can't see it very well, but I assure you that's them running. And not only that, we also showed before that I can see the live images in each of the matrices too, just because I did that debugging in there too. And likewise, mine, I use the inverted because my matrices are upside down, and I can't get to where that currently is set up to turn around the other way. So, although I could do it in my matrices, don't get me wrong, I could have an inverted matrix. Not an issue. That's definitely possible. And I think that's it. Sorry, it's been 54 minutes. That's not bad for me for an hour. Last thing, I don't think I showed it to you, is this thing here. This is the tool I use to make that sprite deck. So I sat and drew these out, made myself a load of images. Obviously, it's an easy tool to use. It's a free tool to use as well. And then what I did is use export, sprite sheet file export. This is one I use, and you can tell it how many columns and rows you'd like to use. It tends to pick. It does a good job at actually picking how many is the most condensed. So that's one here. So you just download that, and I think we're good. And in the, like I say, in the repo, you are going to get access to this this already, and the pixel file too, so you can even open it in there. Final, which I should have said right at the start, is this bit here, important information. So if you are a colleague, there is a competition clause in this license agreement. So the competition clause, I'll probably put this at the start of the video too, which says that if you have watched this video or use it or take inspiration from it, that's all good, more than happy. But anytime you do a LinkedIn post on it, you're gonna have to use hashtag Coding Bytes, just somewhere, just a little hashtag Coding Bytes. So just to spread the love. Okay. All right. Well, I hope you enjoyed that Coding Bytes. Quite a long one, but there you go. Now you can see how my one works, and we'll take it from there. Hopefully that's all good. All right. Speak soon.